All right, guys, I want to start talking about the warm-ups. So the first warm-up problem we had was y equals the absolute value of x. So the way that we should look at that is we put it in our calculator. You had to go to y equals. To get to that absolute value of x, where did you have to go first? Math. So you have to go to math, and then you have to go over to num to get to that absolute value. So looking at this again, I only have these three equals highlighted because I just want to look at the first three. So when I hit graph, there they are. That's the original. That's the one that was absolute value of x plus 3. And then the red one is. And then this black one is the one that was the absolute value of x plus 3 like this. So what did the red one do? It shifted what? Up 3. So it's still that V shape, but it went up 3. And then what about this one? What did it do? It went to the... Is that what you thought it would do? No. Usually people think that that's going to take it to the right because of the x plus 3. So when it's on the inside, it actually does the opposite of what you would think. That actually takes us to the left 3 instead of to the right 3. Outside, up or down, inside, left or right, and it's the opposite of what we would think. Okay, so these were all V's because of the absolute value. Okay, now I'm going to turn those off, turn these on by highlighting the equals. Oops. Well, I wasn't finished. It wants to go ahead. I just don't like seeing all 6 of them at once, so I want to turn some of them off. So I'm going to turn this off, turn this off, turn this off. Okay, so what kind of shape do we get on y equals x squared? Parabola, a U shape. What did this one do? Took it down 2, down 2. This one took us which way? Right 2. Look at it again. So the green is going, there's the original, and the green is going down 2 because of the minus 2 on the outside, and then that red one was x minus 2 on the inside, and it took us to the right 2. Okay? This is what we're trying to learn, is all these transformations of parent functions. What I need you to do now is to pull up your notes that we started on Friday. So if you could pull those up from your Google Drive. This is section 1.1. So our goal for today, while you're finding that, is we want to be able to describe transformations. We want to be able to describe whether the function should be going up, down, left, right, etc. We want to be able to find domain and range, and we want to be able to graph functions. We only use our graphing calculator to check our work, not to do the whole thing. We just want to check with it. All right, so you don't have to take notes if you don't want, but I think it does help a lot of people. First of all, we have to understand what the parent functions look like. The parent functions are the most basic function in a family. Transformations are going to change the size, shape, position, or orientation. But if we narrow that down to translations, translations don't change the size or the shape. All they do is they're going to shift us to the right, to the left, or up or down, but it does not change the size or the shape. Here's our most basic of parent functions. Anytime you see f of x equals a number, this is called the constant function. F of x just means y, so this is really y equals 1. Would everyone know that's just a horizontal line, y equals 1? Okay. What about x equals 1? What kind of line is that? Vertical line, right. A linear function of y equals x, remember, f of x is just y. That's going to be this slanted line like this. Anytime we see just y equals x, not squared, not absolute value, that is going to be a line, okay? If we see y equals the absolute value of x, that is going to be this V shape. So absolute value is always going to give us a V, always. We get lines here. If we put absolute value around it, it really takes all these negatives and flips them up there and makes it into a V. If we have y equals x squared, then we get this shape, which is called what? Parabola. But we only get parabolas if x is getting squared. All right, we need to know these horizontal translations. If we have f of x plus or minus h, this is going to be a translation, either left or right. When we replaced x with x minus h, that shifted it to the right. You have to highlight that or something. X minus h is going to take it right. If we replace the x with x plus h, that's going to do the opposite. Replacing the x with x plus h, that's going to take it to the left. When it's on the inside of the parentheses, it's the opposite of what you would think. Minus h, right. Plus h, left. When it's on the outside, if we have a k value on the outside of the function, not inside the parentheses, but on the outside, when we add k, it takes us up. So plus k takes us up, and subtracting k takes us down. Okay? So that's a little bit easier. It does what you would think it would do. All right, we're going to do an example now. For the following, describe the transformations. Make a table of values using the parent function and f of x. Then state the domain and range of f of x in both inequality form and interval notation and graph. All right. This is the whole entire function, but we just want to look at the parent function. The parent function is y equals the absolute value of x. We're going to make the table of values always using just -2, -1, 0, 1, and 2. So we are supposed to take the absolute value of those numbers. Sam, what happens if I take an absolute value? What's the number become always? Positive, because it's distance. So these numbers are going to be 2, 1, 0, 1, 2. Just taking the absolute values of those numbers that we chose. Now we're going to look here. This x minus 4. Right there. Elise, what do you think that x minus 4 is going to do? Okay, do you know which direction? You're right. That's going to take us to the right 4. So I'm going to start off, I'm going to just graph this parent function. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So here's what the parent function looks like. Okay, that's our parent function. But now we're going to have to take all these points and move them to the left, to the right 4. This x minus 4 is going to take these points to the right 4. So what does that mean I'm going to do with all these x's? Subtract 4 or add 4 to move it to the right? Add 4, right? All right, so I'm going to add 4 to all of these numbers. Let's see. Jackson, can you do that for me? Add 4 to all those?
3, 4, 5, 6.
Okay, good. Okay, what about this at the end now? This plus 2 right here. This is not inside with the x, it's on the outside. Alex, what's it do when it's on the outside?
It moves it up or down.
And what's the plus going to do?
Move it up.
Up 2, good. So now we have to take all of these y values and move them up 2. So I'm going to have 4, 3, 2, 3, 4. Now, these are going to be our new points that are on our graph. So we're going to have 2, 4, and we could plot all these points, but I actually think it's easier to do this. Just take the vertex and shift it to the right 4 and up 2. Take that vertex and shift it to the right 4 and up 2. And then just make the exact same shape. So this is going to go up 1 over 1, up 1 over 1, like that. And this is going to go up 1 over 1. Okay? And that's going to be our new function. I want you to know that you can always check your work on the calculator. I'm going to clear all this out. And just clear, clear, clear. So watch how we put this in here. We go under Math, Num, absolute value, x minus 4 plus 2. Graph. And does that look good? Yeah. I can also look at my table of values, second graph, and I'm going to look at my table of values and check some of these points. 2, 4. Good, we got it. 3, 3. See how I'm checking those? 4, 2. So now we know we're correct. We did that right. Domain and range. The domain of this function is all real numbers. In interval notation, that's going to be negative infinity to infinity. The range is the y values we can use. What's the lowest y value we're using on this new function? What is it, Jolie?
We switched spots.
You did. I'm like, what? That's not true. What is it? 2. So it's going to be y is greater than or equal to 2. Okay? So then, how do we write that in interval notation? What are we going to do? Yep?
Bracket 2 and then infinity.
Good. Nice. All right. Questions on that? How did I know it was a V shape? What told me that? Absolute value. Okay? In my last class, people started on their homework, and they were making everything V's. Not everything's a V, only if we see absolute value. All right, let's go to the next one. All right, so looking at this one, this is the parent function. Y equals x squared is the parent function. Okay? We're going to make a table of values. -2, -1, 0, 1, and 2. The parent function is just to square these now. So square all of these. Audrey, can you tell me what you get if you square them all?
4, 1, 0, 1.
Great. All right, so that would be how the parent function would look. It would be 0, 0. I would go out 1, and then 1 squared is 1. I would go out 2, and 2 squared is 4. I'd go the other way 1, 1 squared is 1. -2 squared is 4. If I went out 3, 3 squared is 9. Go out 3, 3 squared is 9. That's the quick way to graph it. There's the parent function. Now we're going to apply our transformations. All right, so let's look and see what's going on here. So the x got replaced with an x plus 2. Colin, what do you think that's going to do? Shift is what? Good. So we're going to have to go to the left 2. And then what about this -5 down here? Madeline, what do you think the -5 is going to do? Good, down 5. All right, so I'm going to be figuring this out up here. You guys figure it out at your seats, the new points. Now, some people do best using those points and plotting them and connecting them. But I'm going to show you another way to do this. From this vertex, all I have to do is go left 2 and down 5. Now, from there, I'm just going to use that same pattern I used on the original. So if I go out 1, I go up 1, out 1, up 1. If I go out 2, I'm going to go up 4 from there. 1, 2, 3, 4. 1, 2, 3, 4. And that's because 2 squared is 4. If I go out 3, but I have enough points. 5 points is enough. And there's the way that new function should look. And if we wanted to, we could check it out on our calculator. Let's just do the domain and interval notation. We don't have to use inequalities. So the domain and range. Let's go with you, Garrett. Do you know what the domain and range would be?
All real numbers.
All right, negative infinity to infinity for the domain. But then the range, what's the range going to be? Kyla, do you think you know the range? Good job. Okay, that would be as an inequality. You could write it like that. Would it just be greater than or equal to? Equal to, yeah. That would be as an inequality. So what about interval notation? Do I use a bracket or parenthesis? What do you think, Natalie? Bracket. So we're going to go -5 to infinity with a bracket. Okay? All right, guys, let's talk about something else now. What about if we put a negative in front of the function? If we have a function and we put a negative, we multiply the function by a negative, it's going to reflect it over the x-axis. Did you guys learn that before? Okay. So that's how we can do a reflection in the x-axis. It changes those y values. If we want to do a vertical stretch or shrink, then we have to multiply the function by a number. If the absolute value of that a value is greater than 1, we're going to have a vertical stretch. If the absolute value of that a is less than 1, then we're going to have a vertical shrink. So if I have a function and I multiply it by 3, 3 is greater than 1, it's a vertical stretch. If I have an a value of -1/3, the absolute value of -1/3 is 1/3, that's less than 1, so that would be a vertical shrink. Basically, you see a fraction that's less than 1, it's a vertical shrink. All right, we're going to do this with a linear function now. How do I know this is a linear function? It just has an x. That's why it's a linear function. The parent function is just y equals x. So I'm going to use my -2, -1, 0, 1, 2. Y just equals x, so it's going to be the same thing. What does the -1/2 do though? Well, that's a multiplier. So now I'd have to multiply all of my outputs by -1. So I'm going to have to take all of -1/2. I have to multiply all of these by -1/2. Okay, so see if you can do that at the same time I am. Multiply all of these by -1/2. Are you able to get those values? Multiplying it by -1/2. Now, what does this +3 do to it? What's the +3 going to do to it? Shift it up 3, right? Up 3, guys. So now I have to take all these y values and I have to go up 3. So I could use these points now to graph this function. I don't really think you guys need to do that though, because I hope you remember how to graph this line another way that's easier. Do you guys know? You can do x and y intercepts. Let's do it that way actually. Do you know the y-intercept? What's the y-intercept? That's easiest. 3. So the y-intercept is 3 because of that number. So it's 0, 3. Right there. To find the x-intercept, we have to, an x-intercept, plug in 0 for y, and solve for x. To find an x-intercept, plug in 0 for y, and solve for x. Try to do that. Plug in 0 for y and solve for the x. Hello. Yeah. Can I call you just 5 minutes? Okay. Okay, thanks. Bye. Okay, so we're going to plug in 0 for y, and we've got this. So we would now have to subtract the 3. How do I get rid of this negative 1/2 in front of the x? Right, multiply by negative 2. And so we're going to get 6 equals x. So the x-intercept then is going to be 6, 0. And now we have 2 points, and we can just connect the dots. Does anyone remember another way to graph this? Once I knew the y-intercept was 3, how can I graph it? Yeah.
Start at 0, 3, and then go up 1 and left 2, and up 1 and left 2.
Yes, very good. So I can start here at 3 and use my slope. I can go down 1, right 2, or up 1, backwards 2. That's another way to graph a line, okay? But make sure you know that's a line. That is not a V, that's a line. Okay, guys, we're just going to do one more. Let's do example 5, and we're not going to do a chart this time. I'm going to show you how to do this without a chart. Guys, we know normally the parabolas, remember how this is a parabola because it's x squared? Okay, so normally they start at 0, 0, but what is this going to do? Shift us to the, what is it, Ava? Right 1, good job. And then what's this do? So, I know normally it was a 0, 0, but now I'm going to go to the right 1, down 3. There's where it's going to start. Now, normally on a parabola, I go out 1 and up 1. But what else does this have happening? It has a vertical what? Stretch or shrink, you guys? Shrink, because it's, yeah. So it's going to be a vertical shrink of 1/3. So what that means is if I go out 1, instead of going up 1, I'm going to go out 1 and up, what's 1 times 1/3? 1/3. So I'm going to go out 1 and up 1/3. If I go out 2, I normally go up 4, but now I'm going to go up 4 times 1/3, which is 1 and 1/3. If I go out 3, how much do I usually go up on a parabola? 9, but what am I going to go up now? 3, good job. And that's the fast way to graph this. Do I make a V now? What do I make? A parabola, a U shape. And it needs to look like a U shape. Some people try to get by making a shape that kind of is like a mixture of a V and a U, and they're like, oh, that was a U, not a V. But you got to know that. It should look rounded out if it's a parabola there. Okay, guys, domain. Do you know the domain? Yep, and we'll do interval notation. What about the range? Yep.
Y is greater than or equal to -3.
Okay, I like it. Can you do it in interval notation?
Bracket -3, infinity.
Good. Okay, we want x-intercepts. X-intercepts means that I have to replace the y with 0. How do I solve this? I need to get rid of the -3. What do I do? Add 3. Now the 3's gone. I need to get rid of the 1/3. What do I do? Multiply by 3. I have 9. Now, here's where it gets tricky. People just say, I'm going to take the square root and I just put 3 here. But I have to put 2 numbers here. Because something squared has to give me 9. Is 3 squared the only thing that gives me 9? What else does? Right, so I actually have to do 2 things here. I have to say this is when I take the square root of an equation plus or minus 3. Square root of something squared is just this. See if you can finish this and find the x and y intercepts. Oriana, do you have it? Not yet? Okay. Anybody know the x-intercepts? What do you think, Alex?
-2, 0, and 4, 0.
Let's see if that looks right on our graph. -2, 0, 4. That looks good, doesn't it? Yep, that's right. Y-intercept, you had to plug in 0 for x and solve for y. Anybody find that? What'd you get on that, Natalie? -2 and something? Okay, let's see. I'll do it with you. So it's 0 minus 1 is -1, squared is 1. 1 times a third is 1/3 minus 3. What is that, guys? 1/3 minus 3. -2 and 2/3. Good. Awesome. Okay? Let me show you what you have to do for homework. If you go to Canvas, go to today's date of Tuesday, August 22nd. Is it the 22nd or the 21st? Okay, those dates are wrong up there. All right, and then you'll see right here that you are to do this right here, Big Ideas assignment. You're just going to click on that, download it to your Google Drive, and then just use Kami to annotate it, and that'll be your assignment for today. Guys, let's just review real quick. What kind of shape is this right here? Line. What's this one? Parabola. Okay, so just thinking of that as you're graphing. All right, excellent job today. That is all I've got.